Good morning, everyone. So our topic for today is about transaction management. So when you say transaction management, this is how you're going to handle different transactions in a database. So what are these transactions? So when you say transactions, it refers to all the processes which involves data in the database. It's not plainly reading or accessing or viewing the data, but when you say transaction, it refers to an action in the database that has an effect to the data. So a data can either be inserted as new, or a data can be updated, or a data can be deleted. So we call these transactions. Now, first, we have to define what a transaction is. So when you say a transaction, it is a logical unit of work which contains several SQL statements. So these SQL statements can either be insert, update, or delete. Now you have to remember that when you say transaction, it is considered as an atomic unit of work. So when you say atomic unit of work, it will be executed all at once or as a single unit or not at all. So it's just very similar in procedures and triggers. It's an atomic unit. It should be executed at altogether at once or not at all. Okay. Now, when you say transaction, it can be terminated, or it will end with either a commit or a rollback action. Okay. So when you say commit in SQL, it is permanently saving the changes into the database. When you say rollback, you are going to undo the changes that you have made in the database. But when you say commit and rollback, there is a limitation as to where or up to where you can roll back or undo your changes. Okay, so let us first try to check the different parts of a transaction. So when you say a transaction, it will always start with the begin statement. It's either begin transaction or start transaction. Okay, and then after that statement, because the begin transaction or the start transaction will prompt your RDBMS that you are going to execute an atomic SQL statement. It's a series of SQL statement that needs to be executed as one. Okay. Now, after that, after the begin transaction or start transaction, then your SQL statements that you wanted to execute, and then you will end it by either a commit or rollback. So when you say commit, as mentioned earlier, it's permanently saving the changes into the database. And when you say rollback, it's undoing the changes that you have made. But you have to take note that you can only roll back a transaction that is not committed. Meaning, the moment that you commit a particular transaction, you will not be able to roll it back. It's permanently saved. Okay? And then when you say roll back, you can only roll back the transactions that were uncommitted. You can roll back up to the last committed transaction. So example, transaction 1, you have it committed. Transaction 2, 3, and 4, you did not issue a commit statement, but rather issue a rollback. So remember the last transaction that you have committed is transaction 1. So when you issue rollback after transaction 4, then you will be rolled back to transaction 1, which was the last committed transaction. Okay, but you cannot roll back transaction 1 because you already committed. You've permanently saved it into the database. Remember, this is just the same when you do do the Microsoft Word thing, when you do the encoding in your document, for as long as you did not save your work, you can undo the lines that you have typed. But the moment that you saved your work, you cannot undo what you have saved. Now, example, you have typed in the Microsoft Word a paragraph. After a paragraph, you saved it, and then after saving, you add 2 more sentences, but decided not to include those 2 additional 2 sentences. So what you do is that you undo your action. So your action will be undone up to the first paragraph that you have saved, but the paragraph that you have saved cannot be undone anymore. So rollback and undone works like that. Okay. Now, what is the basis for transaction? When you're going to create, what are the requirements that your transaction will ensure the consistency or the integrity of your database? So in database, we have this, what we call the ACID model. So your transaction must possess these criteria so that your database will ensure its reliability or its consistency. When you say consistency, it's correct state. Okay, so let's do this one by one. By the way, ACID is an acronym. So let's go for A. When you say A, it stands for atomicity. When you say atomicity, it is considered as a single unit, or a transaction will be executed as a single unit, not part by part. So it's either you execute it all at once or not at all. That's how atomicity works. Now, when you say C, we call it consistency preservation. So this is ensuring that your database is at a correct state after a transaction is being executed. So when you say consistency, you have to make sure that every data that you have in your database is correct after a transaction is being done. So basically, the consistency part here, or the consistency preservation part, is primarily being handled by your database administrator or database programmer, because it is the logic behind how the program works that will make your data correct or consistent in your storage. So basically, it's the logic, how the programmer understand the logic of the transaction. So that's preserving consistency. So basically, it is the programmer who will ensure that how he or she interprets the flow of the transaction, or how things are done, are being translated correctly in the program or in the application, making sure that whatever data is being processed, or whatever data processed in the program, will be stored correctly into the database. So it's just that making sure that 1 + 1 is equal to 2. So the logic behind it, okay? Next is I for the ACID. It's isolation or independence. When you say isolation, it refers to whatever updates that are currently being made by a transaction should not be made visible or available by other transactions, particularly for uncommitted transaction. So let's have, for example, when you do enrollment, diba? When you did the enrollment online, what happened? Example, student A enrolled in IT 2R1. Okay, then I have here student B is currently not enrolled in IT 2R1, but wanted to check all the possible subjects that he can enroll for the semester. So as what they call this one, As a faculty also, I will be able to search the students who are currently enrolled and not yet enrolled. Now, if I go search student A, I can see there that student A is already enrolled into R1. Okay. Now we have student B who is currently enrolling. Remember, when you do enroll, you are going to select the section where you wanted to enroll and select the subjects that you wanted to enroll. Then register. After registering those subjects, then you will see there your subjects. Then you need to click on the save button for you to permanently enroll the subjects, right? Now, the moment that student B chose a section and selected and registered the subjects that he wanted to enroll, that is not yet committed. It's not yet saved into the database. So while student B is doing that, I, as an instructor, will not be able to see what student B is doing. What I can see is student B is a BSIT student who is not yet enrolled. No subjects enrolled for the current semester. But at the end of student B, he is now currently in the process of enrolling the subjects. It's just that he did not save his enrollment. So as long as student B will not save his enrollment or his registered subjects, then I, as the faculty, will not be able to see what are the subjects that he chose to register. That's isolation. That is to prevent inconsistency in the data, in the database. Because the moment the transaction will occur, your database is temporarily at an inconsistent state. Now, to prevent this inconsistent state, have an issue with other user, the property of isolation should be enforced. Okay. Next is D, durability or permanency. Now, we have student B. So he selected his section and subjects and registered, and then he clicked on saved. The moment that he clicked on save, unsay mahitabo, I, as the faculty, will now be able to see the subjects that student B has enrolled. And then those subjects will be permanently saved into the database. Okay, when you say durability, either hardware or software failure, even power interruption will not affect or will not have an effect to the data. So after student B saved his enrollment and pre-SAMs went down, so not a software failure, the enrollment will still be there for student B. The subjects enrolled for student B will still be saved in the database. It will not be lost. So another scenario, if in case after student B has saved his enrollment, there was a power interruption. So the moment na the student saved it, automatically, even though there is a power interruption, there will be no effect into the data, or the data will not be lost. It's the same when there is a network failure or a hardware failure. It should not have a negative effect into the database, meaning all data are intact. No lost data. That's for durability. Now, there is an additional property for what they call this one, a transaction. We call it serializability. So when you say serializability, this is a property of a transaction that if you are going to execute it sequentially, that is 1, 2, 3, 4, 5, you will have the same output if you are going to execute it in an interleaved way. Example, when you have transaction 1, when you're going to execute it sequentially 1, 2, 3, 4, 5, you'll get an output. But the same transaction, If you're going to execute it in an interleaved way, example 1, 3, 2, 4, 5, you will have the same output. So that's serializability. Okay. Now let us try to check what are these MySQL transactions. So these are the properties, or these are the parts of your MySQL transaction. As mentioned, you have your start transaction or begin statements for your new transaction. So each new transaction should start with start transaction or begin statement, and then it will end with either a commit or a rollback statement. Okay, so when you commit, of course, when you end it with a commit, of course, you cannot roll it back. If you end it with a rollback, of course, no transactions or no changes has been made into the data in the database. Okay, but you have to take note that the MySQL has set an auto commit. So if you have noticed, when you do the insert, the update, automatically changes are saved in the database. So by default, MySQL has it, or has the settings to be in auto commit. So for you to be able to do the commit or rollback, you can disable the auto commit. So before you start the transaction, you can have the set auto commit is equal to 0 or set auto commit is equal to false. It will enable the auto commit command or the default command in MySQL. Now, part of transactions are what we call the save point, roll back to save point, and release save point. Okay, so when you say save point, it is a statement that sets a named transaction save point with the name of the identifier. So you have their save point and then the name of that particular identifier. So it pertains to a certain transaction. Okay, you are giving a name to a certain transaction in which it will save as a, what they call this one, as a point where when you say you are going, that serves as a demarcation, as a mark that when that particular save point is being read, all transactions will be committed or rolled back, depending how you have defined your save point. So if the current transaction has a save point with the same name, then the old save point will be deleted. So ma-overwritten ang old nga save point. And then the save points of the current transactions are deleted if you execute a commit or a rollback and that does not have a save point name. So a new save point level is created when a stored function is invoked or a trigger is activated, and the save points on previous levels must become unavailable and thus do not conflict with save points on the new level. When the function or trigger terminates, the save points it created are released and the previous save point level is restored. So basically, when you say save point, how can I explain this out? When you say save point, I created a transaction and named a transaction. So I have your save point and then the name of the save point. So when I have a transaction that has a save point, by the term itself, save point, my transaction should end by a commit statement. Okay. Now, if I will create another transaction and uses the same and have it as a save point and uses the same name as my previous save point, then my new transaction or my new save point will override the previous save point that I have created. Okay. Then another behavior of a save point is that I have created a save point. Now, I did some transaction. And when I say roll back to save point, the succeed or the transaction that ended with the rollback to save point will undo the changes that I have made up to the save point, up to the last transaction which contains the save point that I have created. Okay, so when the function or trigger terminates, any save points created are released and the previous save point level is restored. Now, when you say rollback to save point, it rolls back a transaction to the name save point without terminating that transaction. So, wala nimo gi-end ang transaction, imo lang siyang gibalik dito sa save point. So, modifications that the current transaction made to the rows after the save point was set are undone in the rollback, but does not release the rows lock and were stored in a memory after the save point. Hence, save points that were set at a later time than the name save point are deleted. Now, we also have what we call release save points. So when you are going to say release save point, you're going to remove the save points that you have committed. So it is a statement that removes the save point from the set of save points of the current transaction. So it's either no commit or rollback has occurred, and it is an error if it will give an error message if you are going to issue a release save point to a non-existing save point. All right, so let's have an example here for save points and transactions. So let's have a table here titled or named names. And then for this particular statement, you're going to display all the data from the names table. So you have here select all from names. So you have to take a look particularly on the data. Okay, observe what are the output for this particular what I call this one, for this particular query before we did a transaction. Okay, so we have four what I call this one data. Now let's initialize a transaction. Okay, so we created a transaction by having start transaction, and then after defining or after telling the compiler that we are about to execute a transaction, we created a save point, and it is named as initial saved. Okay, so after that, we did this series of SQL statements inside our transaction, right? So we have start transaction, and then we created a save point, which is initial save. Now we have here the update statement. So in the update statement, we are going to update the table names, particularly for the ID, for an ID, which we will set 414, where first name is equal to Harry. So unsay tugan ni si Harry? Original niyang ID is 4. Now, in our update transaction, we are going to update the ID number of Harry into 414. So, if you are going to do an update, ang mahitabo dayon is ma-change initially na-change ang ID number ni Harry from 4 to 414. Okay, this is the changes that has occurred after we did the update. Now we did a rollback to initial save. So what was the data before before initial save? So, di ba initial save? So inhitabo, di ba kini the original table. So when we do rollback to initial save, we are going to get the original data, which is 4 for the ID number of Harry. So that's rollback to save point. So when you do rollback to save point, you are the data will be rolled back or will be undone, or the changes will be undone to the last correct state before the save point that we have created. Okay. So basically, rollback to save point rolls back a transaction to the named save point without terminating the transaction. So as you can notice, the transaction has not been terminated because you did not when you did the rollback to save point, because you did not end your transaction by either a commit or a rollback statement. Instead, what you issued is a rollback to save point. Okay. So now let's go to the lock and the locking and unlocking tables. So locking and unlocking tables will tell a transaction if the transaction can proceed or not. Okay. So when you say locking of tables, that is what we call this one, exclusively the table will be available to a transaction that has acquired or requested a lock to that particular table first. All other tables will not be able to access it unless, or not tables, transactions rather, all other transactions will not be able to access it unless it is being, or the lock is being released by the previous transaction. So your MySQL, it will automatically enables lock and unlock a table each time a transaction will perform changes into a particular table that's locking the table. And when the transaction is done, then the table will be unlocked and other transactions can then, what we call this one, can then access the table. Okay. So lock tables explicitly acquires table locks for a current client session, and table locks can be acquired for base tables or views. So unlock tables explicitly releases any table locks held by the current session, and lock tables implicitly releases any table locks held by the current session before acquiring new lock. Now let's go to concurrency problems. So it's really okay if you have a database and you only have one user. Concurrency problem will not occur. However, in reality, there is no such thing as a single user database. We know that if we have an application or if we have a system, it is expected that there are multiple users, and these multiple users will access the system at the same time. Okay, so it's when there is a multiple users with multiple or accessing the database at the same time, concurrency problems will occur. So let's go to the different concurrency problems. So first is what we call the lost updates. So when you say lost updates, example, you have two transactions trying to update the same data in the database, and the second transaction overrides the update that were made by the first transaction. So the update that was overridden is what we call the lost updates. So let's have, for example, this table. We have transaction 1 that will update the product quantity on hand with 100 units, meaning na ay niabot nga sa from supplier ng 100 ka buok, so akong i-increase ang inventory or ang product quantity on hand. For transaction 2, nakabaligya og 30 ka buok, meaning i-minus siya sa quantity on hand kaya na ay nagpalit. Okay, so when you say lost update, this is the scenario of a lost update. Transaction 1 at time 1 access product quantity on hand, which is currently 35. At the same time, transaction 2 access product quantity on hand with the same value. Read pa man, di ba? At 35. Okay. Now, after transaction 2 has access product quantity on hand, transaction 1 updated the product quantity on hand by adding 100 units to it. Now, before transaction 1 was able to commit the changes, transaction 2 updated also product quantity on hand by deducting 30 units from it. Kaya di ba nakabaligya si transaction 2 of 30 ka units. Now, what will happen? At the end of transaction 1, si product quantity on hand, himong 135. Kaya wala pa man niya na nakita tong di-minus ni transaction 2. Na pag-abot ni transaction 2, 5 na lang niyang nakita. So, dapat unta ang makita nato kay 105. Because ni-add si transaction 1 og 100, dapat pag human ni transaction 1 og add, nag-commit, aya pa dayon nag-minus si transaction 2 og 30. So, 135 na dayon minus 30. So, in this case, the update of transaction 1, asa gani ining update ni transaction 1? The update of transaction 1, this one here, this one is what we call lost update. So the correct way on how the transactions should be executed is like this. You have to let transaction 1 to commit or to finish its update before transaction 2 will be allowed to read and update the same data, which is product quantity on hand. So in this case, transaction 1 reads product quantity on hand at 35 and then updated it with 100 units and commit. So, nahimo na siyang 135. After it committed, then transaction 2 will be allowed to access product quantity on hand. So, it will now be 135 and update it by recording the 30 units sold. So, minus or deducting the 30 units from the product quantity on hand, which will give you now a balance of 105. So that's that's the correcting entry or the correct way on how the transaction should be executed. So I hope last updates is clear. Now let's go to uncommitted dependency. So when you say uncommitted dependency, it occurs when a second transaction selects a row that is being updated by another transaction. And the second transaction is reading an uncommitted update by the first transaction. Okay, so let's have an illustration. So given, di ba, na natay transaction 1, na mag-purchase of 100 units, nag-purchase of 100 units. So dapat i-add. However, ang nahitabo, instead nga i-add niya ang 100, instead nga i-commit, iyang gi-roll back. Right? Now, here comes transaction 2. Dapat i-record niya or i-update niya to 30 ka buok nga nabaligya. Okay. So, let's try to check this. What will happen? So, transaction 1, ang nahitabo, nag-read siya ni product quantity on hand. So, 35. Tapos, nag-update. And then, Pag human niya update, or wala pa siya na mag-update actually, nagkuan na-read na dayon na access na ni transaction 2 ang product quantity on hand, which is still uncommitted, nga 135. So 135 ang na-access ni transaction 2, in which dito niya gi-base ang iyahang pag-minus sa 30 kabuok nga nabaligya. So 135 minus 30. However, before pa na-complete ang transaction ni transaction 1, mao man tong time nga na-access ni transaction 2. Instead niya si transaction 1 iyang i-commit, iyang gi-rollback. So what happens? Gibalik to 35. So mali na dayon ang mahitabo pag end ni transaction 2 sa iyahang update. Kay gi-rollback ba ya ni transaction 1? So imbes of adding 100, imbes nga 135, gibalik niya to 35. However, si transaction 2, ang iyahang nabasa is 135. Gimaynusan niya og 30, nahimo na yung 105. So matingala ka, lain-lain og nakita. So this is what we call uncommitted dependency. Okay, when a second transaction updates or reads the uncommitted transaction by the first transaction. So this is the correct execution of transaction 1 and 2 to prevent uncommitted dependency. So dapat mahuman sa jud si transaction 1. Okay, pag human ni transaction 1, what is transaction 1 ended with a rollback. So pag rollback niya, may balik siya 35. So pag human na ayha pa dayon ma-access ni transaction 2 ang product quantity on hand, which is now has been returned to 35. And when you deduct 30 from it by the number of units sold by transaction 2, you will get 5 units as a balance for quantity on hand. Okay, so that's for uncommitted dependency. Now we have also the third one, we have inconsistent retrievals. So this is very similar to uncommitted dependencies. So that is two transactions are trying to update the same data. For the first transaction, it's uncommitted. It's not yet committed, or the uncommitted data is being read by transaction 2, and the data is the data is changing from time to time nga i-access siya. So this is uncommitted inconsistent retrievals. So we have here an example. Si transaction 1 and transaction 2. For transaction 1, ang iyahang buhaton is i-select niya or i-total niya, isum niya ang product quantity on hand. Sum. Recall the say tawag ano niya? Aggregate functions in SQL. Di ba when you say select sum, then the column name from the table, it will total the values of the column of that particular column. Now, that's for transaction 1. Muna siya yung gusto buhaton, i-total niya ang product quantity on hand. Si transaction 2, iyang buhaton is ga-update siya sa mga specific data under product quantity on hand, sa mga specific record. So nag-update siya plus 10 sa product quantity on hand for the particular code 1546-QQ2. Sa product code pod nga 1558-QW1 is mag-minus siya og 10. Mao ni ang gusto buhaton. So naagi na siya effect. Okay? Kay whatever changes nga imong buhaton sa imuhang product quantity on hand nga column, Nagi na siya effect diri sa pag-sum nimo. Matingala ka kada sum, lain-lain og answer, dili na mag-tagbo. Okay? So we have this inconsistent retrieval. So ang nahitabo ani, sige nahitabo. Let's try to trace. Now transaction 1, di ba the entire column man ni product quantity on hand ang ato ang i-total ni transaction 1. Now the product quantity on hand na siya row, na siya specific. Unsa man iyang specific contains the product code. Okay? Now mahitabo, so pag read niya sa product code nga 11QER/31, na siya value nga 8. So pag total ana 8. Okay. Now pag next na po niya nga row, pag next row niya sa product quantity on hand column, naadayin siya 32. So 8 plus 32, 40. Sakto ra. Karon, kamulo pang update si transaction 1, wa pa siya na-complete, nisulod na din si transaction 2. Si transaction 2, iyahang giduga ang nahitabo, iyahang gi-update ang product code nga 1546-QQ2 nga currently na ay 15, gidugangan niya 10. So nabutangan diri og 15. Di ba 15 originally, gidugangan niya 10, himong 25. Nya kay wala pa man to gi-commit po di transaction 2. Ang nahitabo transaction 1, ang nabasa niya is the uncommitted changes made by transaction 2, which is 25. So nahimo na yung 40 plus 25, so 65 na. Ang nabasa ang total ni transaction 1. So padayon na po si transaction 1. Dili na po siya sa 15 product code 1558-QW1. 23 plus na siya 23. So 65 plus 23 na akay 88. Now, wala pa na human na access na pod ni transaction 2 ang product code 1558-QW1 nga 23 ang iyang nakita. Okay? Gimaynusan niya og 10. So, ang nahitabo 23 minus 10, nahimo na lang 13. 13 na lang siya. Gi-commit dayon ni transaction 2. Unya kay wala pa man nahuman si transaction 1 kay i-total in ang entire column. So ang iyang mabasa na dayon is pila man? 88 na. 88 na to no. Which is wala na reflect ang katunggi minus 10. First is wala na reflect si minus 10. Okay? Igadungan man silang access. So ang nahitabo 88 iyang basa kay the same man ni sila nga quantity product code QW1. Okay, ang nabasa rin niya si 23. Wala na niya nabasa ang 10. Tapos ang nahitabo 88 plus 8 na rin kay 96. Plus 6 na kay 102, which is mali. Dapat manggod na total sa na-appeal pagbasa ang plus 10 ug ang minus 10. Okay, so lain-lain. So if you will do the correct transaction sequence, dapat ang mahitabo kay asa na to? Ang mahitabo ani kay dire. Pag-abot dinhi, humanon dapat tanan ni transaction 1 ang iyahang pag-total before si transaction 2 ma-execute. Okay. So dapat unta 8 plus 32 plus 15. So 8 plus 32, 40. Plus 15, 55. Tama? Okay. So ingana dapat pagkahumanda yon, dapat nakita ni niya ang minus 10. Dapat mo 96 sila. So ang hitabo ingani. So 8 dungan sila no. 8 plus 8, 8. Ay, 8 plus 8. 8 plus 32, 40. Kani. Dapat pagbasa dayon ni transaction 1 o katong 15 bitaw asman to. Kani. Ang mahitabo si transaction 2 unsay buhaton? makumit niya daan ni, i-commit ni niya, kani bitaw. Dapat diri pa lang iyahan ni siyang gi-commit after nag-25. Okay. Pag na-commit niya, so 25 na, mo na po dahil ni ang mabasa ni transaction 1, dili na 15. Pagkahumanda yon, kato din QW1, si transaction 2, iya sa itong makumit daan, which is nahitabo, ay mabasa ni transaction 1. So, dapat 13 ang mabasa ni transaction 1. Ay dayon ang the succeeding transactions, which will lead you to a total of 92. This is to prevent inconsistent retrievals. Okay? That is why you have to make sure that all your transactions will adhere to the ACID property. So what are those? Naakay atomicity, consistency preservation, isolation or independence, and durability. And the last one, ang dugang is serializability. So bisan pag imo na siyang isaksak sinagol o execute, it will lead to the same answer, 92. Dili dapat ma-change. That's serializability. Whether you execute it this way or in an interleaved fashion, you should always get the total of 92 rather. That is to make sure that a transaction or that particular transaction is serializable. All right? Now, with this concurrent transaction of multiple users into the database, there is this what we call scheduler. So, ang trabaho ni scheduler, siya ang mo determine if the transaction can, what they call this one? The transaction can now access the data or wait for the data to be available. Okay. So, when you say scheduler, it is the one who establishes order of operations in the database. So the scheduler interleaves the execution of database operation to ensure serializability and isolation of transaction. And to determine the appropriate order, the scheduler bases its action on concurrency control algorithms, such as locking or timestamping methods, which are explained in the next sections. So when you say serializable schedule, it is a schedule of which a transaction, which is executed interleaved, yields the same result if the transaction is executed serially or sequentially. Moto kung giingon ka ganina, whether the transaction 1 is executed 1, 2, 3, 4, 5 or 1, 3, 5, 4, 2, they will have the same output. Okay. So we have this concurrency control with locking methods. So when you say locking methods, natay ginatawag nga lock manager. Si lock manager, siya ang responsible for issuing lock to the transaction. So this lock, natay ginatawag nga lock granularity. It can be a database, table, page, row, or field lock. So when you say database lock, medyo dili man siya nga naka-ideal because daghan mang user magamit. So for example, if you're going to access Prism, when you say database lock, if student A will access Prism, other students will not be able to log into Prism unless student A will finish its transaction into the database. So that's a very great disadvantage. Okay, that's database lock. Locking an entire database for a particular transaction. No other transaction will be able to access it unless mahumana siya. Naput tayo table level lock. So when you say table level lock, it's an entire table will be locked for a particular transaction, in which it's way better than database lock because it's a very specific one in a particular table. However, in a scenario where you wanted to enroll, imagine 15,000 students of USTP would like to enroll, they cannot access the enroll table because there is a transaction who is currently being who is currently using it, who is currently holding the lock for it. So dili gyapon siya ideal. It's not that ideal because the other 14,999 will have to wait for one particular transaction to finish before they can enroll. So it's not that ideal. Next is the page level lock. So it will refer to the memory address. So if your table or if the data that you wanted to access is on the same memory address, then that memory address will be locked. So other parts of the database, other parts of the table that is not part of that memory address can still be accessed by other transactions or other users. So basically, it's more ideal. Kaya kung unsa laman ang na staged ana ang memory address, mao man ang malak. Kung naara po dito ang imong gusto nga data i-access, mao po ang malak. It refers to the memory address. But basically, when you say locking granularity, it's more of a combination of page lock or a row lock or field level lock. Pag may kag row, isa ka record ang i-lock. Pag moingon ka o field, isa ka column ang i-lock. So basically, it's a combination of the three para mas paspas ang proseso sa sulod sa database so that other transactions can still be carried out even though there are parts of the database that are currently being used by one transaction. Okay. So regardless of the level of locking, the DBMS may use different lock types. We have what we call binary or shared or exclusive locks. So when you say binary, 1, 0. Pag may kag 1, lock. Pag may kag 0, unlock or available. Pag may kag 1, no other transaction, meaning lock siya, meaning no other transaction can access it. Pag may ka og available or unlocked, other transaction may access it. Okay? Now we also have what we call shared exclusive locks. So when we say shared exclusive locks, the lock is or the data is being shared and exclusively locked by one transaction. Shared siya with another transaction if wala pa changes nga mahitabo. Pero kung naa na gani i-execute nga changes ang isa kang transaction, i-exclusive na din siya ana nga transaction nga lock. So ang mahitabo ana is like this. If what we call if example transaction 1 and transaction 2 wanted to update the enrollment of student A, ang mahitabo kung both transaction 1 and 2 will just read student A, walay buhaton, iya lang i-select, that's shared lock. Shared, kay sila man duha naka-access si transaction 1 and 2. But the moment that transaction 1 will update the enrollment of student A, then that's the time that transaction 1 will be able to acquire the exclusive lock for student A para malikayan ang potential conflict. Okay? So that's shared and exclusive lock. Pag mahuman na si transaction 1, then balik na po sila ma-shared or ma-release na din ang lock. Okay? So basically shared exclusive locks, the shared lock is applicable if two transactions are just reading the data. But when one transaction would like to execute changes, then the transaction that will execute changes will acquire the exclusive lock for that particular data. Okay? Then after that, pag ma-commit na, then ma-unlock na dayon to siya adto nga particular transaction. Ma-release ang lock sa data. Now, let's go now to two-phase locking. So when you say two-phase locking, this is how a transaction will acquire and relinquish locks. So in two-phase locking, it will guarantee serializability, but it will not prevent deadlock. Okay? So there are two phases of two-phase locking, the growing phase and the shrinking phase. So let's go directly to the illustration. I'll just discuss the illustration for you to understand it. Now, example, transaction 1 would like to, or let's have transaction 1. So when you say growing phase, transaction 1 are acquiring locks for different data na iyahang gusto i-update. Okay? Iyahang gusto i-change. So, acquiring the locks for those data is what we call the growing phase. Pag na-lock na dahil ni transaction 1 tanan ang data nga iyahang gusto i-change, mo na siya ang gibutang nato nga lock point. Okay, naa na siya sa lock point. Pag abot niya sa lock point, isa-isa naman din i-execute ng changes, no? Pag mahuman siya sa isa ka data o execute sa changes, i-release niya ang lock ato nga data. Now, data number 2, iyan na pong i-execute, release na po. Now, the releasing of locks after executing the changes is what we call the shrinking phase. Until nga mahurot na gyud og ka-release ang tanan nga lock for the data nga na-acquire ni transaction 1. So let me recall, acquiring of locks for the different data is what we call the growing phase. Pag naana tanan ang lock, kompleto na, we call it the lock point. Then pag naana sa lock point, that's the time nga maka-execute si transaction sa changes. Now, executing the changes will lead to releasing of lock gradually, one by one. So the releasing of lock is what we call the shrinking phase. All right. Now let's go to deadlock. So unsa gyud ini si deadlock? What is with deadlock? So ang deadlock mo ni siya ang mahitabo ni deadlock. Example ha, nag-malfunction ang traffic light sa SM. Di sa Osmeña man, no? So, nag-ilog ang mga sakyanan sa makapabor lang. Now, ang katong padulong o Gaisano, gusto mo tabok, padulong Gaisano. From Gaisano to USTP, gusto mo tabok. And then, ang from Osmeña to Agora, gusto, to Osmeña Extension, gusto mo tabok. From Osmeña Extension back to, kuan magdungan ba, magdungan. So, nagtagbo sila tanan sa tunga, there's no way for them to move forward, no way for them to move backward. That's what we call deadlock. Dili na mairog. Okay? So, posible na siya mahitabo kang database. So, paunsa na siya nga scenario mahitabo kang database? If there are two transactions. Okay. Si transaction 1, currently, gi-access niya ang data nga si transaction 1, iyahang gi-hold ang lock ni transaction X. Ay ni data X. Nakalock sa iya si data X. Then gusto niya i-access si transaction, si data Y. Now here comes transaction 2. Si transaction 2, gilock niya, nakahold, siya ang nakalock kang transaction, kang data Y. Remember ha, si transaction 1, na-lock sa iya si data X. Gusto niya i-access si data Y. Here comes transaction 2, na-lock niya si data Y. Gusto niya i-access si transaction X. Now, T1 will not release the lock of transaction of data X, and T2 will not release the lock of data Y, in which transaction 1 would like to access Y, and transaction 2 would like to access X. So what will happen? They are waiting for each other to release the lock of the data that they are currently holding. Okay, until nga wala siya action. So that's naghinulatay ra yun. So that's the time that deadlock will occur. So that's how deadlock will occur. Now, there are 3 basic techniques on how you are going to prevent or to control deadlocks. Number 1 is what we call deadlock prevention. Second is deadlock detection. And the third one is deadlock avoidance. So when you say deadlock prevention, si scheduler palang daan or si scheduler or si transaction manager will try to check if the transactions requesting for data locks will cause a possible deadlock. Pag makita niya kung posibleng nga magka-deadlock si ang transaction 1 and 2, iyahan na siyang i-abort. Dili wala siya i-grant. Dili niya ipa-continue to nga mga transaction. That's deadlock prevention. So wala deadlock prevention. So wala pay execution na hitabo, gikat na daan ni transaction manager. Now, deadlock detection. Ang mahitabo sa deadlock detection, giallow na nga ma-execute ang mga transaction. But during the execution of these transactions, ma-detect man dayon ni transaction manager kung asa ato nga transaction ang maka-cause of deadlock. So kung unsa to nga transaction ang maka-cause of deadlock, mao iyahang i-abort. So, di ba ang difference ni prevention ug ni detection? Si prevention, wala pay gi-allow nga may execute nga transaction, makita na niya ang possibility of a deadlock. Yarin tong kung kinsa to nga transaction ang involved for possible deadlock, automatic i-abort. Whereas if deadlock detection ang mahitabo, nag-execute na, gi-allow na ma-execute ang mga transaction, gina-check ni transaction manager asa ato nga mga transactions ang maka-cause for deadlocks. Kung na siya ma-detect, tapos ihadayon tong i-abort. That's for deadlock detection. Now, when you say deadlock avoidance, ang mahitabuan ng deadlock avoidance, before a transaction can execute or can be executed, dapat ma-acquire sa niya tanan ang lock. Kung naay isa ka data nga dili niya ma-lock, dili siya pwede ma-execute. That's deadlock avoidance. Okay? So, wala pa siya ka-execute, kay naay nakita si transaction manager nga possibility nga maka-cause of deadlock. So hulaton nga ma-release ang lock adto nga data para makuha ana nga transaction, then that's the time that the transaction can be executed. Okay? Now we also have what we call concurrent control with time stamping methods. So, unsa ning time stamping approach? So, it is approach to scheduling where concurrent transaction are being assigned with global unique timestamp. So, naka-timestamp na tanan imuhang transaction. So, bisan pag mag-ingon mo nga dungan mo click, dili gyud na siya mahitabo, kinaagi na sila time difference. Okay? So, the timestamp value produces an explicit order in which the transactions are being submitted to the DBMS. And it must have 2 properties, uniqueness and monotonicity. So, in time stamping natay gitawag nga weight die scheme. So, unsa ni si weight die scheme? So, if the transaction requesting the lock is the older of the two transaction, meaning mo'y nakauna, it will wait until the other transaction is completed and the locks are released. So, ang mahitabo ani, if the transaction requesting the lock is younger of the 2 transactions, then it will die or it will roll back, i-reschedule. So, sa weight die scheme, ang mahitabo, di ba, transaction 1 o si transaction 2. Now, si transaction 1, ang nakauna o sa linya, kumbaga, Nagsunod si transaction 2. Kung si transaction 1 ang nakauna sa linya waiting for the data nga iyang gusto i-access to be unlocked, then ipahulat siya until nga ma-unlock to siya nga data. Then ihatag dito kang transaction 1. Now, si transaction 2, kay younger man, ang mahitabo, kinag-request ng po siya the same data, nag-request si transaction 1, since transaction 2 is the younger transaction, it will die. Manang wait die scheme. Unsay mahitabo, nganong die? I-reschedule siya. I-reschedule siya. Since gadung pareha silang data nga i-access, nga currently being locked by another transaction, i-identify dahil sa timestamping algorithm kung kinsa ang una o kinsa ang ulahi nga nagpa-request og lock. Ang una ipahulat, ang una nag-request pahulaton para maka-acquire, para siya dahil ng next na mo-hold sa lock atong data. And then the younger transaction or katong ikaduha nga transaction nga nag-request of the same data will be rescheduled. That's what we call the wait die scheme. Okay? Naputay giingon nga would wait scheme. So when you say would wait scheme, if the transaction requesting the lock is older of the two transaction, it will preempt the younger transaction by rolling it back. So if the transaction requesting the lock is younger of the two transaction, it will wait until the other transaction is completed and the locks are released. So ang mahitabo ni would wait scheme is if nakay duha ka transaction, gusto nila i-access si data A. Now, si transaction 1 ang nakauna. So ang buhaton dayon ni timestamping nga scheme kaning wound wait, iyahang i-preempt or iyahang i-wound si transaction 2 nga iyahang ipahulat og balik, i-reschedule niya balik. Or kung makita niya si transaction 1 ang nakauna. Pero kung makita niya nga ang nag-request sa lock is ang si transaction 2 which is ulahi, yang buhaton ipahulat niya si transaction 2 nga ma-release tong lock nga mahuman si transaction 1 ay padayon siya. Mo na siya would wait. Opposite po siya, lahi po siya ni die scheme, wait die. Diba si wait die ang mahitabo, transaction 1 is the older, nakauna sa linya si transaction 1, sunod si transaction 2. So kung makita niya ni transaction manager nga si transaction 1 ang ga-request, unsay buhaton gani sa algorithm, iyang pahulaton si transaction 1 nga ma-release tong lock sa data para si transaction 1 ang musunod. Pero kung ang makita niya nga ang ga-request sa data is si transaction 2, which is the younger transaction, iyahang i-reschedule. Motong maday, iyahang i-reschedule. Okay? Diri ang mahitabo pod sa wound wait, transaction 1 and transaction 2. So nakauna si transaction 1, pag makita niya na si transaction 1 ang nag-request, which is the older transaction, automatic iyang i-roll back or iyang i-reschedule ang transaction 2, which was the younger transaction. Pero kung si transaction 2 gani ang mo request, ang mahitabo, iyang pahulaton si transaction 2. Maghulat si transaction 2 nga mahuman ang transaction 1. Di ba? Primero nakalock. Pag ma-release to, makuha ni transaction 1. Pag human ni transaction 1, si transaction 2 dayon. So maghulat ra si transaction 2 kung siya ang nag-request until nga mahuman si transaction 1 anak nga data. Okay? That's for the wound wait scheme. Now, we also have what we call the optimistic approach. So, it is based on the assumption that the majority of the database operations do not conflict with each other. And it requires neither locking nor timestamping techniques and is executed without restrictions until it is committed. So using this approach, transaction moves through 2 or 3 phases referred to as read, validation, and write. So unsay mahitabuan ning optimistic approach. So sa read phase, kato pa lang ning tanan nga wala kay computation, imo lang i-view ang tanan nga data. Viewing lang yun siya sa data. Okay? So wala pay mahitabo. Now, pag humanay sa read phase na ading kay gitawag nga update or nag-execute nimo tong transaction pero wala pa siya gi-commit. Gibutang mo siya og temporary nga location or temporary nga file. So wala pa after the reading or after selecting the data that you wanted to change or to update, pag nag-update na dayon, dili pa siya ma-commit diretso. It will be placed in a temporary file. Pag naana siya sa temporary file, tapos dito na dayon ang validation phase. So pag validation phase na gani, dira dayon i-check if kani ba siya nga transaction kay maka-cause og conflict or dili. Kung maka-cause og conflict or concurrency problem, i-restart to siya nga transaction, dili ipadayon, dili i-commit. However, kung dili gani maka-affect or dili gani maka-cause of problem or issue, then the transaction will go to the write phase. When you say write phase, it will permanently save the changes into the database. No na siya ang commit nga phase. So that is for the optimistic approach. Then let's go to database recovery management. So when you say database recovery management, dito ma-apply ang durability nga part sa transaction. So when you say database recovery, it restores the database from a given state to a previous consistent state, meaning ma-restore nimo ang database from the last consistent state. So pag naakay natin tayo tinatawag ng mga recovery techniques. So based on the atomic properties, all portions of the transaction must be treated as a single unit of work. So meaning isahon ra gid siya tanan og execute. So what are the events that might cause failure na atay gitawag nga hardware or software failure? Pwede nga human caused incidents or natural disaster. Pag human caused na gani, gituyo gyud nga naay breach or ma-sacrifice ang database. So paunsa man nimo siya i-recover to the last consistent state. Pag natural disaster katong na in case of fire, in case nga mabahaan, ana. Okay? Hardware or software, pag kag hardware, nabakahay ni naputo sa network, naabakay ni buto sa imuhang somewhere sa imong servers, or pag may software failure, nag-down ba ang system. So these are the events that you will need to identify para maka-execute ka og katong recovery techniques. So naatay transaction recovery, we call it the write-ahead log protocol. So this protocol ensures that the transaction logs are always written before any data is updated. So mo ni siya ang trigger nga before update usually mo work. So tanan gyud gituyo nganong before ang update mahitabo ka in kaso that the execution of the update will cause a problem. Pwede ka mo balik dito sa imong gihimo sa trigger nga before update, imo tong balikan. So that's write-ahead log protocol. So this protocol ensures that in case of a failure, the database can later be recovered to its consistent state using katong imuhang data log nga na-generate sa before update trigger. Napatay gitawag nga redundant transactions logs. So when you say redundant transaction logs, you will create multiple copies anang imuhang transaction karon. You will create multiple copy so that if ever nga naaga ni failure ang database, pwede rin nimo balikan ang isa. Pwede mo kuhaon ang isa nga kopya. Dito rin ka magsugod o balik. That's for redundant transaction logs. We also have what we call database buffers. So these are temporary storage areas in the primary memory to speed up these operations and to improve processing time. So the DBMS software reads the data from the physical disk and stores copy of it in a buffer. Nana siya sa buffer sa ato ang primary memory. Then we also have what we call database checkpoints. So these are operations in which database or the DBMS writes all of its updates or updated buffers to disk. So kumbaga, nakay-update dito, primero man na siya mabutang sa buffer, no? Sa buffer pa man na siya tanan mabutang para mas fast ang processing. So pag may database checkpoints, naakay certain operation nga pag maabot na ani nga part, dapat ma-save na tanang update permanently sa disk or sa database. That's for what they call this one, database checkpoints. All right, so that's all for transaction management. So I will be giving you an activity through UStep so that you will be able to practice transaction management. So apil dira si SafePoint. I will be uploading all the what they call this one, activity in the UStep. Okay? So that's all for today, and thank you for listening.